Hello students, let's discuss about data warehouse architecture. A data warehouse is constructed by integrating data from multiple heterogeneous sources. It supports analytical reporting, structured and or ad hoc queries and decision making. Some data warehouse reference finite set of source data, or as with most enterprise data warehouses, reference a variety of internal and external data. Because constructing a data warehouse is unique to the business use, we will look at the common layers found in all data warehouse architecture. The data warehouse architecture includes the following layers: data source layer, data staging layer, data storage layer and data presentation layer. Let us see about data source layer and its function. The data source layer of data warehouse architecture is where original data collected from a variety of internal and external sources resides in the relational database. This layer stores disparate data types including operational data, for example, product data, inventory data, marketing data or HR data. Next, social media data, for example, website hits, content popularity and content page completion. Third, third party data, for example, demographic data, survey data and census data. While most data warehouse architecture deals with structured data, consideration should be given to the future use of unstructured data sources such as voice recordings, scanned images and unstructured text. These streams of data are valuable pieces of information and should be considered when developing the data warehouse. Next, we can see the function of data staging layer. The data staging layer resides between data sources and the data warehouse. In this layer, data is extracted from different internal and external data sources. Because source data comes in many different formats, the data extraction layer will utilize multiple technologies and tools to extract the required data. Once the extraction of data has been completed, it will be subjected to high level data quality checks. The final result will be clean and organized data that you will load into your data warehouse. The staging layer contains the following components: landing database and staging area and data integration tool. We will discuss about landing database and staging area first. The landing database stores the information retrieved from the data source. Staging is used to apply quality checks on the information before moving it into the data warehouse. Staging is an essential step in data warehouse architecture. Poor data will amount to inadequate information and result is poor business decision making. Next, we will see the important thing, data integration tool. Extract, transform and load tools, which is nothing but ETL, are the data integration tools used to extract data from the source system, transform and prepare data and load into the data warehouse. Next, we will see about data storage layer. The data storage layer is where data that was cleaned in the staging region is stored as a single central repository. Depending on the business and data warehouse architecture requirements, data storage may be data warehouse, data mart, it is nothing but data warehouse partially replicated for specific departments, or an operational data store, which is nothing but ODS. Next, the function of data presentation layer. Next, the function of data presentation layer. The presentation layer is where users interact with the cleaned and organized data. This layer of the data warehouse architecture provides users with the ability to query the data for the product or service insights, analyze the information to conduct hypothetical business scenarios and develop the automated or ad hoc study. An OLAP or reporting tool with a user-friendly graphical user interface, which is nothing but GUI, can be employed to help users to build their queries, perform analysis or design their reports. When planning your data warehouse, create one that will handle both structured and unstructured data and is cross-functional. It should also provide a long-term foundation for data provision and decision support. Next, we can discuss about business analytic framework. The business analyst gets the information from the data warehouses to measure the performance and make crucial adjustments in order to win over other business holders in the market. The data warehouse offers the following advantages. Number 1, since a data warehouse can gather information quickly and efficiently, it can enhance business productivity. Number 2, a data warehouse provides us a consistent view of customers and items, hence it helps us manage customer relationship. The next advantage is a data warehouse also helps in bringing down the cost by tracking trends, patterns over a long period in a consistent and reliable manner. To design an effective and efficient data warehouse, we need to understand and analyze the business needs and construct a business analysis framework. Each person has different views regarding the pattern of the data warehouse. These views are as follows. First is the top-down view. This view allows the selection of relevant information needed for a data warehouse. The next view is the data source view. This view presents the information being captured, stored and managed by the operational system. Next, the data warehouse view. This view includes the fact tables and dimension tables. It represents the information stored inside the data warehouse. Next, the business query view. It is the view of the data from the viewpoint of the end user. Next, we are going to see the 3-tier architecture. The data warehouse adopts a 3-tier architecture. Following are the 3 tier of the data warehouse architecture. First, bottom tier. The bottom tier of the architecture is the data warehouse database server. It is the relational database system. We use the backend tools and utilities to feed the data into the bottom tier. These backend tools and utilities perform the extract, clean, load and refresh functions. Next, we will see about middle tier. In the middle tier, we have the OLAP server that can be implemented in either of the following ways. First, by relational OLAP, which is nothing but ROLAP, which is an extended relational database management system. The ROLAP maps the operation on multidimensional data to standard relational operations. Next method is by multidimensional OLAP, which is nothing but MOLAP model, which directly implement the multidimensional data and operations. Next, top tier. This tier is the front-end client layer. This layer holds the query tools and reporting tools, analysis tools and data mining tools. The diagram shows the 3-tier architecture of the data warehouse. Next, we can see about data warehouse models. From the perspective of data warehouse architecture, the following are the data warehouse models. Number 1, virtual warehouse. Number 2, data mart and number 3, enterprise warehouse. First, we will see about virtual warehouse. The view over an operational data warehouse is known as virtual warehouse. It is easy to build a virtual warehouse. Building a virtual warehouse requires excess capacity on operational database servers. Next, we can discuss about data mart. Data mart contains a subset of organization-wide data. This subset of data is valuable to specific groups of an organization. Data marts contain data specific to a particular group. For example, the marketing data mart may contain data related to items, customers and sales. Data marts are confined to subjects. The important points to be noted about data marts are: Windows based or Unix or Linux based servers are used to implement data marts. They are implemented on low monetary value servers. The implementation data mart cycles is measured in short period of time, that is in weeks rather than the month or years. The life cycle of the data mart may be complex in the long run if it is planning and design are not organization wide. Data marts are small in size. Data marts are customized by the departments. The source of a data mart is departmentally structured data warehouse. Data mart are flexible. Next, we will see about enterprise warehouse. An enterprise warehouse collects all the information and the subjects spanning an entire system. It provides us enterprise-wide data integration. The data is integrated from operational systems and the external information providers. This information can vary from a few gigabytes to hundreds of gigabytes, terabytes or beyond. Next, we will discuss about load manager. This component performs the operations required to extract and load process. The size and complexity of the load manager vary between specific solutions from one data warehouse to another. Next, we are going to discuss about the load manager architecture. The load manager performs the following functions: extract the data from the source system, fast load the extracted data into temporary data store, performs simple transformations into structure similar to the one in the data warehouse. Extract data from source. The data is extracted from the operational databases or the external information providers. Gateway is the application program that are used to extract data. It is supported by underlying DBMS and allows client program to generate SQL to be executed at a server. Open database connection, which is nothing but ODBC, Java database connection, which is nothing but JDBC, are examples of gateway. Next comes the fast load. In order to minimize the total load window, the data need to be loaded into the storage warehouse in the fastest possible time. Transformations affect the speed of data processing. It is more effective to load the data into the relational database prior to applying transformations and checks. Gateway technology proves to be not suitable since they tend not to be performant when large data volumes are involved. Next, we will see about simple transformation. While loading, it may be required to perform simple transformation. After this has been completed, we are in a position to do the complex checks. Suppose we are loading the EPOS sales transaction, we need to perform the following checks. First, stripe out all the columns that are not required within the warehouse. Next, convert all the values to the required data types. Next, we are going to see about warehouse manager. A warehouse manager is responsible for the warehouse management process. It consists of third-party system software, C program and shell scripts. The size and complexity of warehouse managers vary between specific solutions. Next, we are going to see the warehouse manager architecture. A warehouse manager includes the following components. Number 1, controlling process. Number 2, stored procedures or C with SQL. Number 3, backup or recovery tool. Number 4, SQL scripts. Operations performed by storage warehouse manager are: A warehouse manager analyzes the information to perform consistency and referential integrity check, creates index business views, partition views against the base data. Next, generates new aggregation and updates existing aggregations, generates normalizations. Next, transforms and merges the source data into the published data warehouse, backup the data in the data warehouse, archives the data that has reached the end of the captured life. A warehouse manager also analyzes query profiles to determine index and aggregations are appropriate. Next is query manager. The query manager is responsible for directing the queries to the suitable tables. By directing the queries to appropriate tables, the speed of querying and response generation can be increased. Query manager is responsible for scheduling the execution of the queries posed by the user. Next, we are going to see about query manager architecture. The following screenshot shows the computer architecture of the query manager. It includes the following: query redirection via C tool or RDBMS, stored procedures, query management tool, query scheduling via third party software. We will see about detailed information. Detailed information is not kept online, rather it is aggregated to the next level of detail and then archived to tape. The detailed information part of data warehouse keeps the detailed information in the Starflake schema. Detailed information is loaded into the data warehouse to supplement the aggregated data. The diagram shows the pictorial impression of where detailed information is stored and how it is used. If detailed information is held offline to minimize disk storage, we should make sure that the data has been extracted, cleaned up and transformed into Starflake schema before it is archived. Summary information. Summary information is a part of data warehouse that stores predefined aggregations. These aggregations are generated by the warehouse manager. Summary information must be treated as transient. It changes on the go in order to respond to the changing query profiles. The points about summary information are: summary information speeds up the performance of common queries, it increases the operational cost, summary information needs to be updated whenever new data is loaded into the data warehouse, it may not have been packed up since it can be generated fresh from the detailed information. To conclude, a data warehouse is constructed by integrating data from multiple heterogeneous sources. It supports analytical reporting, structured and or ad hoc queries and decision making. A data warehouse is subject oriented as it offers information regarding a theme instead of company's ongoing operations. These subjects can be sales, marketing, distribution. There are 5 main components of a data warehouse. Number 1, database. Number 2, ETL tools. Number 3, metadata. Number 4, query tools. And number 5, data marts. The 4 main categories of query tools are query and reporting tools, application development tools, data mining tools, OLAP tools. In the data warehouse architecture, metadata plays an important role as it specifies the source, usage, values and features of the data warehouse data. Thank you.